Hi Honors Bio students, I'm here today to show you the other method for solving a dihybrid cross. We talked about the forked line method, which may make a lot of sense to some people, being able to multiply those probabilities. And it's actually much more efficient when you're looking at multiple traits to use the forked line method, and it will be the method that's used in AP Bio. So please keep that in mind if you're planning on taking AP Bio next year. Please familiarize yourself with that forked line method. However, the other method uses a 16 square Punnett square, and it's a lot more visual, and so it's easier, I think, for most students to understand. So this also will help you understand a dihybrid cross and predict the offspring. So either way is fine. Neither one's wrong. I will say the forked line method, again, will be used probably in AP Bio, so just keep that in mind. But here's the Punnett square method. I'm going to do the same problem that I did with the forked line. So we're looking at tomato plants, right? So we have the fruit color, which was red or yellow, or tall or short tomato plants. So we're looking at two traits, right? Because it's a dihybrid cross. So we read through the problem, we figured out what it was asking for, and we made a key, right? So here was our key. The dominant trait for fruit color was red. The recessive was yellow. The dominant allele, I should say allele, the dominant allele for height was tall and the recessive allele was short. So you have two different traits. You have fruit color and you have plant height. Okay, so we're looking at two traits. So you have this 16 square Punnett square. It's easy to set up. You just draw a square or a rectangle, right? And you can divide it in evenly. So you draw the square and then you do a line down the middle, a line through here, so like an X, and then divide it again each way. And that'll give you 16 squares. So now we have to figure out the combination of alleles to put on the top and the side. So one parent's combination of alleles will go on the top and the other parent will go on this side. And the way that we figure out the combination of the alleles is the FOIL method. So a lot of you will be familiar with the FOIL method from mathematics, right? So FOIL stands for first, outer, inner, and last. So that's how we figure out the alleles. So let's take a look at how that works. So we take one parent at a time, okay? So the first parent, you do the first of the two traits. So that would be capital R and capital T. Okay, so that's your first combination of alleles. Your second combination of alleles is outer. So the first and the last, that's your outer. Okay. Inner is these two, right? Do it here. So that's inner. And then last. Okay. So first was capital R, capital T. Capital R, capital T. Inner was the capital R, capital T. Looks like we're gonna have a trend here. Also, my orange marker stopped working. Okay, inner. So we had first was capital R, capital T. Outer, capital R, capital T. Inner was again capital R, capital T, and last, capital R, capital T. It's not, obviously that's not always gonna work out like that, okay? But it just happened to there. But do you see what I did? Again, it's the first two, outer, inner, and then last. Okay, so let's do it for the other one. So we have first, so it'll be RT, capital R, capital T. Outer, capital R, lowercase t. Inner, be lowercase r, capital T, and then last. So lowercase r, lowercase t. So be consistent also about which trait you put first. So in this problem, I put the plant color first and then the plant height. So definitely be consistent about that. And then when you're bringing these alleles down to find the offspring, you also want to be consistent about putting the capital letter first. Okay, so when we're looking at this first square, you bring these two alleles down and over. So it'd be capital R, capital R, capital T, capital T. Same with this one, it's down and over, capital R, big T, This one, capital R, big T, and you can see we have a little bit of a pattern with this Punnett square. How about this one? Capital R, big T, lowercase t, capital R, big T, little t. We do have a little bit of a trend going with this Punnett square for sure. So you can see that most people, again, like this is very visual and you're doing this, but it does take more time than the forked line method. Okay, and then this last row looks like it's all the same. Big T, little t, big T, little t. So it's not always going to work out like this where all of these have the same genotype. Just letting you know, it's not always going to be like that. So in this 16 square Punnett square, you're going to have to search through and find all the different combinations. It just so happens with this cross, this whole row is the same, okay? So 1/4 is homozygous dominant for each trait. 1/4 is homozygous dominant for fruit color and heterozygous for height. 1/4 is heterozygous for fruit color and homozygous dominant for height. And 1/4 is heterozygous for fruit color and heterozygous for height. So remember from the forked line method, what was the phenotype of all of these? They all have at least one dominant allele for both of the traits. So they're 100% red, tall plants. Okay? So that's how you do the Punnett square method for dihybrid crosses. Again, forked line or the Punnett square, they're both very acceptable. So I want you guys to master at least one of them. If you have any questions, watch the video again, post on the discussion board or send me an email.